Hello everyone and welcome to Sally and Bytes. Today, I am here to teach Exception Handling Part 2, Standard Exceptions in Python, Common Python Exceptions with Practical Implementation, for the Class 12 students of Computer Science. So, let's dive in and get started. Let's discuss about the standard exceptions in Python. So let's recall what we learnt in the previous video. What is an exception? Irregular, unexpected situations occurring during runtime are called exceptions. Exceptions may occur even if the program is free from all types of errors. What is exception handling in Python? Python provides us a way to handle exceptions so that the script does not terminate but executes some specific code when an exception occurs. This concept is called exception handling. Note: an exception can be addressed by its name. Python has some built-in exception names for common exceptions. If required, a programmer can also define his or her own exceptions. When an exception occurs in a program, we say that exception was raised or thrown. Next, we deal with it and say it is handled or caught. And the code written to handle it is known as exception handler. For handling exceptional situations, Python provides raise statement to raise exception in the program. Assert statement. An assert statement in Python is used to test an expression in the program code. And try except statement for catching and handling errors. Try except statement will be covered in the next video, Exception Handling Part 3. So now, let's learn about the raise statement. Python raises an exception whenever it tries to execute invalid code. The raise statement can be used to throw an exception. It interrupts the normal flow of the program and passes control to the exception handling mechanism. It allows you to throw an exception at any time. Let me explain in detail. Raise statement allows the program to force a specified exception to occur at runtime. Python automatically raises an exception when it encounters an error during the program execution. Once an exception is raised or thrown, it is up to caller function to either handle it using try except statement or let it propagate further. The syntax is raise of exception name of message or argument of traceback. Here, exception name is the type of error, which can be string, class, or object. It is an instance of exception class. Argument is the value or parameter passed to the class. It is a short message that describes the error. You can also give your own message for notifying error to the user. As the argument is optional, its default value none is used in case the argument is not provided. Traceback section succeeds the argument when any exception is raised or thrown. Let's see an example for raising or throwing an exception. Look at the yellow box. Line 1 assigns the value 100 to the variable x, line 2. This line starts an if statement that checks if the value of x is greater than 50. Line 3. If the condition in the if statement, x greater than 50, evaluates to true, this line raises an exception. An exception is a signal that indicates that an error or unexpected event has occurred during the execution of the program. In this case, the exception being raised is of type exception, and it includes the message x should not exceed 50. Let's see the output. Traceback, most recent call last. This line indicates that Python is displaying the traceback, which includes information about the sequence of function calls that led to the exception being raised. It starts with the most recent call and goes back through the call stack. The next line provides information about the location of the error. It tells you that the error occurred in a file named raiseException1.py at line 3. Next line is the code that raised the exception. It tells you that an exception was raised with the message x should not exceed 50. Last line shows the type of exception that was raised, exception, and the message associated with it, x should not exceed 50. You can see line that raised the exception, exception, and descriptive message typed boldly in yellow boxes for your reference. Let's learn about the assert statement. An assert statement in Python is used to test an expression in the program code. If the result after testing comes false, then the exception is raised. This statement is generally used in the beginning of the function or after a function call to check for valid input. The syntax is assert expression of arguments. On encountering an assert statement, Python evaluates the expression given immediately after the assert keyword. If this expression is false, an assertion error exception is raised, which can be handled like any other exception. Let's see an example of assert statement. Look at the yellow box for the Python code. Line 1. This line simply prints the message use of assert statement to the console. Line 2 defines a function named -check, which takes a single parameter number. Line 3. This line contains an assert statement. It checks if the number passed to the function is greater than or equal to 0. If it's not, it raises an assertion error with the message "oops, negative number." Line 4. If the assert statement passes, that is, number is non-negative, this line calculates the square of the number and prints it. Line 5 calls the -check function with the argument 100. Since 100 is non-negative, the assert statement within the function passes, and it prints the square of 100, which is 10,000. The output will be the result of this calculation. Line 6 calls the -check function with the argument -350. Since -350 is negative, the assert statement within the function fails, and it raises an assertion error with the message "oops, negative number." The program terminates at this point, and nothing is printed as a result. Let's see the output. Look at the pink box for the output. You can see 10,000 displayed. This value is printed because the function -check of 100 is called, and 100 is a non-negative number. The assert statement within the function passes, allowing the function to compute and print the square of 100, which is 10,000. You can see none displayed below 10,000. This is printed because the function -check of -350 is called, and -350 is a negative number. When the assert statement within the function fails, an assertion error is raised, causing the function to terminate abruptly without reaching the print statement that calculates the square. Since the function does not explicitly return any value in this case, the default return value of a Python function, which is none, is printed. Now look at the traceback. This is a Python error message that shows the sequence of function calls and file names leading up to the error. It indicates that an assertion error occurred in the -check function at line 3 of the file assert.py when the input -350 was provided, as expected due to the assert statement failing. The message assertion error, "oops, negative number," specifies the reason for the assertion error, indicating that a negative number was encountered. Let's see some standard built-in exceptions available in Python. Name error. Raised when an identifier is not found in the local or global namespace. Type error. Raised when an operation or function is attempted that is invalid for the specified data type. Value error. Raised when a built-in operation or function receives an argument that has the right type but an inappropriate value. Zero division error. Raised when division or module by zero takes place for all numeric types. Attribute error. Raised when an object does not find an attribute. Key error. Raised when a mapping, dictionary, key is not found in the set of existing keys. Indentation error. Raised due to incorrect indentation. I/O error. Raised if the file requested cannot be opened, or failure of input or output operation. Index error. Raised when an index is not found in a sequence. That is, out of range or out of bounds. Import error. Raised if Python cannot find the module requested for in a program. EOF error. Raised when one of the file methods, that is, read function, readline function, or readlines function tries to read beyond the file. Syntax error. Raised when there is an error in Python syntax. Runtime error. Raised when an error does not fall under any specific exception category defined above. All the above predefined exceptions can be used with raise statement. Let's discuss these exceptions in detail with example. Name error. A name error in programming typically occurs when you try to use a variable or a function that hasn't been defined yet. It means Python doesn't recognize the name you're trying to use. It is raised when a function name or variable name is not found in the local or global namespace. If you get a name error, check if the variable name or function name has been typed correctly or not, has been given in quotes or defined somewhere else where it is not required. Note: local variables are local. You cannot refer to them from outside the module or function where they are defined. Let's see an example. When writing a function with a name, we often miss calling the exact function name in the future, which will lead to a name error. Now, look at the code. In this Python code, there's a function named calc_sum defined, which takes two parameters x and y. Within the function, it calculates the sum of x and y and stores the result in a variable op. Then, the function returns this result using the return statement. After defining the function calc_sum, the code calls this function with arguments 5 and 10. Here is the name error. It was initially built to conduct some operation between two numbers and named calc_sum, but when we called it, we used the name calc_su, therefore, it had not previously been defined, and it would throw us a name error. The error in this code is likely due to the misspelling of the function name calc_su instead of calc_sum. The function call calc_su of 5, 10 doesn't match the function name calc_sum. Hence the corrected code, S1 equals calc_sum of 5, 10. So the output will be 15. Now, let's see the description of the name error. Look at the red box. Traceback. It describes a list of the functions which were running and displayed at the time of occurrence of the exception. The second line defines the path. I have highlighted in a yellow box. It defines the path where in the program the exception has occurred. That is the name of the program, which is nameerror1.py in the given example alone with the line number 6. The third line shows the actual place of error, that is the statement in which the error has occurred, which is print method. The fourth and the last line explains that the exception has been raised because of the undefined variable calc_su. Thus, from this example, we can say that the exception name error usually contributes as a result of undefined variable. A mistyped variable or function name, the name was to be enclosed within the quotes. Type error. Type error is raised when an operation or function is attempted that is invalid for the specified data type. For example, if we are trying to do the square root of a number but we are passing a list instead of int, then type error will be generated by the Python. Reasons for type errors. When you are trying to use a value improperly, a type error in Python may arise. For example, indexing a string, list, or tuple with something other than an integer. Second reason. There is a mismatch between the items in a format string and the items passed for conversion. This can happen if either the number of items does not match or an invalid conversion is called for. Third reason. You are passing the wrong number of arguments to a function or method. For methods, look at the method definition and check that the first parameter is self. Then look at the method invocation. Make sure you are invoking the method on an object with the right type and providing the other arguments correctly. Let's see an example. Look at the Python code. In this example, you can see that we have created two variables, x and y. Variable x is holding a string hello and the other variable y is holding an integer value 4. Now we are trying to perform division between these variables and hold the result into the third variable, result, and printing the result. But Python will throw type error because an integer cannot be divided by string or character, the Python was expecting integer value, so it throws type error. So you can check the output below as type error on line 3. Value error is raised when a built-in operation or function receives an argument that has the right type but an inappropriate value. Let's see an example. Look at the Python code. This code prompts the user to input their age using the input function, which accepts user input as a string. The int function then converts this input string into an integer and assigns it to the variable age. Finally, the value stored in age is printed to the console using the print function. Now, look at the yellow box to see the output. The output begins with the prompt, "Enter your age." The user is expected to input their age. However, instead of providing a valid integer input, the user entered 20, which is not a valid integer representation due to the presence of the character O. As a result, the int function encounters a value error because it cannot convert the input string, 20, into an integer. Therefore, the program raises a traceback error, indicating that there was an invalid literal for conversion to an integer, that is the value error. Zero division error. Zero division error is raised when division or module by zero takes place for all numeric types. It occurs when in division operation, denominator is inputted as 0. Let's see an example. Look at the yellow box. Result equals 10/0. This will raise a zero division error because dividing by 0 is not allowed in arithmetic operations. Zero division error is a built-in Python exception that occurs when attempting to divide a number by 0. This error typically happens when you attempt to perform division where the divisor, the number you're dividing by, is 0, which is mathematically undefined. You can check the output here, zero division error, division by 0. Attribute error. Attribute error is raised when an object does not find an attribute. Causes for attribute error. Attribute error indicates that an object has a none type, meaning it is none. Forgetting to return a value from a function often leads to this error, as Python automatically returns none in such cases. Using list methods like sort, which return none, without assigning the result can also trigger this error. Attempting to use a method not associated with a particular object, such as using append, on an integer list, can raise this exception. Let's see an example. Look at the Python code. X equals 10, x.append of 6. In Python, an attribute error is raised when you try to access or modify an attribute of an object that doesn't exist or isn't applicable to that object's type. In this code, you're trying to use the append method on an integer object, x, which will raise an attribute error because integers in Python do not have an append method. Here, you're trying to call the append method on x, thinking that x is a list. However, x is an integer, and integers do not have an append method, hence raising an attribute error. So the code should be like this. To fix this error, you need to make x a list if you intend to use the append method on it. So the output looks like list of elements containing 10, 6. 6 is appended or added to the list. Key error. Key error is raised when a mapping, dictionary, key is not found in the set of existing keys. Let's see an example. Accessing dictionary values. Now, look at the yellow box. In the statement, look at the first line. You're creating a dictionary named my_dict with two key value pairs, A:1 and B:2. Dictionaries in Python are collections of key value pairs, where each key must be unique. However, in the subsequent statement print of my_dict is C, you're trying to access the value associated with the key C in the dictionary my_dict. Since the key C does not exist in the dictionary my_dict, attempting to access it will result in a key error. You can check the output of key error here. Index error. Index error is raised when an index is not found in a sequence. That is, out of range or out of bounds. The index you are using to access a list, string, or tuple is greater than its length minus 1. This exception is raised when an index is not found in a sequence. In other words, it occurs whenever we try to access an index that is out of a valid range. Let's see an example. Accessing list elements. Look at the yellow box. In the statement my_list equals list containing elements 1, 2, 3, you're creating a list named my_list containing 3 elements, 1, 2, and 3. Lists in Python are 0 indexed, meaning the index of the first element is 0, the second element is 1, and so on. However, in the subsequent statement print, my_list of 3, you're attempting to access the element at index 3 of the list my_list. Since lists are 0 indexed and my_list contains only 3 elements, the valid indices for my_list are 0, 1, and 2. Therefore, trying to access my_list of index 3 is beyond the bounds of the list and will result in an index error. I/O error. Input-output error. I/O error is raised if the file requested cannot be opened, or failure of input or output operation, such as opening a file that does not exist, trying to delete a file in use, removing USB while read or write operation is going on. In all these situations, where some interrupt occurs in input or output operation, I/O error exception is raised. Let's see an example. Trying to access a file that doesn't exist. Look at the yellow box. Here we're attempting to open a file named nonexistent_file.txt in read mode, R, using with statement. This with statement is commonly used in Python for handling files because it automatically closes the file after the block of code inside it is executed. However, if the file nonexistent_file.txt does not exist in the specified location, Python will raise a file not found error when attempting to open it. This exception occurs when Python tries to access a file that doesn't exist in the file system. You can check the output here, file not found error. Indentation error. Indentation error is raised due to incorrect indentation. Now look at this example. In this example, the print statement is incorrectly indented. That is without spaces, white spaces. In Python, the standard convention for indentation is to use 4 spaces for each level of indentation. In Python, indentation is crucial for defining the structure of code blocks, such as functions, loops, and conditional statements. Below you can see the correct indentation of the print statement. So we can correct the syntax error when the errors are displayed. Thanks for watching. Please subscribe if you are new to my Sally and Bytes YouTube channel to stay updated with engaging content and never miss out on my latest videos. If you like this video, don't forget to give this video a thumbs up. Share this video with your friends and relatives. Watch the upcoming videos, Exception Handling, Part 3. Handling exceptions in Python with practical implementation. You can check the link in the description box given below.